Lekazir anober mai Lekazir anober mai Lekazir anober mai kan triat ngai lo le zir ngai lo te po kan hu lo le kan cho ngai lo te po izir zelang so turin izir zelang so turin Lekazir anober mai Lekazir anober mai Lekazir anober mai.
So there are three important applications of dimensional analysis. One is to check the correctness of a physical equation, and another one is to derive the relation between different physical equation, and the third one is to change from one system of units to another. So now the first one, we shall do the first application of dimensional analysis to check the correctness of a physical equation. Here we have a problem. Check the accuracy of the relation. So half mv square equal to mgh. This is a physical equation, physical relation. There are lots and lots of physical equation in physics. So this is a simple one. So we are going to solve, and I shall explain how we check the correctness of the relation. Okay, so first we shall write a solution. So we are going to solve solution. Okay, solution for this. So this is the first term. We have two terms, 1 2, and this is left hand side and this is the right hand side. Okay, the right hand side. So in order to find out whether they are correct or not, so we shall do the left hand side first and then find out the dimensional formula for the right hand side. Then whether if they are same or if they are equal, that means this equation is correct. Okay, so first let's take the left hand side. Left hand side, what is the left hand side? Half mv square. Okay, so half mv square, so equal to, so we are going to find out its dimensional formula for this term. Okay, but don't take the constant. It can be half, it can be 5, it can be 4, it can be 3, it can be pi also. Okay, some constant. Only we take the variable dimensional formula. So we take the dimensions of m small, m is the mass, and v is the velocity. V is velocity. Okay, and here g is acceleration due to gravity and h is height. So mass, what will be the notation of? We already know that m, capital M. Okay, its power or its dimension is 1 only. And what about this is velocity v? So velocity dimension, what is the dimension for velocity? Let's check it out. V equal to distance by time. We know that distance by time. If you already know, you can apply directly here. For instance, if you forget what is the dimensional formula for velocity here, then you can work it out like this. Distance is measured in meters, so L time t, so L t to the power minus 1. So this is the dimensional formula for velocity. So we can put here 1 like this, but we have here square. Okay, square, so like this. So now we put in one bracket, take it all together. M, L, here we have L, but there is square. This also will include, that means L square. Here also we have to multiply. Minus 1 into 2 is minus 2. So this is the dimensional formula for the first term, the left hand side. Okay, the left hand side. Okay, what about the right hand side? This one, right hand side. Now take the right hand side. Right hand side is mgh. M stands for mass, g acceleration due to gravity, h is height. So m here, and what about g? G is acceleration due to gravity. If you know it, if you know dimension of acceleration due to gravity, you just put it directly here. But if you forget, you work it out like this. Acceleration due to gravity is velocity, acceleration is velocity by time, isn't it? And what about velocity? Velocity is again distance by time. Here we have t already, so that means distance by time square or equal to distance to the power minus 2. So we must put lt to the power lt to the power minus 2. So now we are going to take it again, m, and one more here, height. I almost forgot, but we have to write like this, h, height, l. Okay, so l, so m, and both this is l 1 1. Okay, you must add it and it will be l to the power 2. Okay, so l square t minus 2. Okay, like this. So we have, this is a dimensional formula for mgh, and the second term, the right hand side term. Okay, so now you can check it. Okay, you can check it as m power 1 square minus 2, and here m power 1 l squared minus 2, both are same, isn't it? They are equal. That means from this dimensional formula, this equation, left hand side and right hand side are the same, so this equation is a correct one. Okay, this is a correct one. So we, in the end, usually we have to write like this, since dimensions of left hand side and right hand side are the same. My handwriting is not so good. The given equation is correct. Okay, so this given equation is a correct one. So now this is the way we checked whether the equation is correct or not with the help of dimensional analysis. Okay, first we find out this dimensional formula for the left hand side, and next the right hand side, and we compare it, and then if they are equal, that means the equation is a correct one. Okay, so let me show you from the textbook. Here. Another example, checking the correctness of a relation. Check the dimensional consistency of the equation. But here we have three terms, 1, 2, 3. Before we have 1 and 2 term only, so a little bit different, but it is not difficult, don't worry. A term we can if all the terms are equal, that means the dimensional formula for each term are equal, that means this equation is a correct one. Okay, where S stands for distance m, V stands for final velocity, and U stands for initial velocity. Okay, so we have Fs equal to half mv square minus half mu square. So let's start. Dimensional formula of Fs equal to F is force, mass lt to the power minus 2, lt minus 2 to the power minus 2 is acceleration. So m, this is a fourth dimensional formula, and here we have s l. So all together ml square t to the power minus 2, ml to the power 2 t to the power minus 2. And next is and the right hand side, the first term, half mv square, m l t minus 1 and whole square. Now m l square t minus 2. Now these two terms are same. So let's check the third one whether it is also same or not. Half mu square, m l t to the power minus 1 then whole square, m l square t minus 2. So when we solve each term, then it's come out to be m l to the power 2 t to the power minus 2. So all the three terms are same. So as the dimensional formula of all the terms in the given equation is same, the key equation is a correct one. Okay, this is how we check the equation. There are lots of equations in physics, so it is very easy to check whether it is correct or not. Some equation may be wrong also. So some equation may be wrong. Let's see. Let me give you one equation like this. Okay, we shall check s equal to ut square plus half at square. Okay, so let's check it out whether this equation is a correct one or not. So this we have three terms, 1 2 3, 1 2 3. S stands for distance. Okay, u is also initial velocity, time, a acceleration, t time. So now let's do the first one. Left hand side, s. Here distance, we don't have mass, so dimensions of m will be 0. And what about l? Here we have 1l distance, and time we don't have. So the left hand side dimensional formula is m to the power 0 l t to the power 0. Okay, so now what about the right hand side? Right hand side, the first one. Okay, the first one, u t square, u here velocity. Okay, that means distance by time. And what about t? T square times square. No, m0 here l, but here minus 1 2, it will be the t will be minus 1 plus 2 will be, we should not multiply it here if they are in different brackets. Okay, if they are in different brackets we should not multiply it, then we should add it. Minus 1 plus 2 means minus 1. Okay, so if we compare the first term, the left hand side and the right hand side, now it's already not equal. These two were same, however the third one, here we have time 0 but we have here time, so this will be 1 time, we have time here. Minus 1 plus 2 is equal to 1, isn't it? So here times, but actually there should not be time here. What about the third one? Half a t square. We don't take half. Acceleration is lt minus 2, distance by time square, and time t we have. So m will be 0, and t minus 2 and t2 will be cancelled. Okay, t square by, that means t square. So that means t is 0 also. So these two, in the left hand side term, in the right hand side the second one are same, but the middle one is not same with the other. That means this equation is not a correct one. This equation is not a correct one. So I have checked this equation. So what about, and the real equation will be, I'll just put, let's say in the lower class we learn about s equal to ut plus half at square, isn't it? These two and this two term are already same. Now what about ut? If I put ut, okay, ut, before it was ut square, s is equal to ut plus half at square. Okay, ut, what about right hand side? Ut, distance, u is velocity, distance by time, and here t. So t and t we can cancel out. So that means there is no more t. L, t 0, and if we put m here, so it look like this. So now the actual equation will be s equal to ut plus half at square. Okay, that means this is a correct equation. This is the correct equation. So this is the wrong equation. So we can check like this. This is the correct equation. S equal to ut plus half at square is the correct equation. I think sometimes the wrong one can be given in equations. Okay, so or there may be a printing mistake. That means if you are if you notice something wrong, that means you can check it out. Nang manin in test ni, nang manin in check thaya hai chu trangkai ni. So this is very useful to check whether the given equation, the given physical relation is correct or not. Okay. And one more. Let's try for another one. T equal to 2 pi root L by G. This is time period of simple pendulum. So if you look carefully with the other equation, this equation, and the first one, this equation, first one, this is a little bit different because there is no root and there is no pi and L by G, numerator, denominator, and also root. You may confuse. That's why I will just explain. Okay, in a simple way, time. Let's do it directly without any wording. Left hand side time. T is dimensional formulas m0, l0, t only. We have t only. Okay, and what about this right hand side? Don't take this. The right hand side is let me write. Okay, we don't take the constant, only this. Okay, so this means that we have we used to write when there are roots. We used to write like this, half, because you know that any root x will be x to the power half. These two things are same. Root, square root means to the power half. Okay, so I put instead of this root to the power half. Okay, so here L half. What is dimensions of L? This length L, and this dimensional of this, that means you take half here. No, for this G, let's work it out. G, acceleration due to gravity, is LT to the power minus 2, isn't it? Distance by time square. Okay, so you put distance by time square, but we have half. Okay, we have half. L half, and here L into the power half. Here T minus 2 into half is if you cancel, that means minus 1. So this minus 1. So you can cancel out these two, and here you write 1 by t minus 1, or if it goes up, that means it is simply t. Therefore the right hand side dimensional formula is there is no mass, no length, and here only time. So if you compare this one and this one, these two are same. That means this equation is a correct equation. Okay, this equation is a correct equation. So this is how we solve, and this is how we check the correctness of a physical equations. That's all.